Welcome to my class once more. Please do well to like, comment, share, and importantly, subscribe to my YouTube channel. Today we want to look at a question in radioactivity. It says a radioactive substance has a half-life of 20 days. What is the amount of the substance left after 40 days if the initial mass was 5 grams? In questions like this, first of all, you list out the given. Half-life was given. The half-life. And you know that half-life is the time taken for half of the initial amount of radioactive substance to decay, to become half. So half-life, which is T half, was given to be 20 days. The next thing that was given is activity time. Activity time is the time taken for the whole radioactivity, and it is designated T, which is 40 days. The next thing that was given was the initial count or initial mass. Initial mass. The initial mass, which is N0, 5 grams. Now, the next you do is to find out, very important, number of half-lives in this activity. Number of half-lives. And number of half-lives is designated NT half, which is the activity time over half-life. Activity time is 40 days, half-life is 20 days. Therefore, number of half-life is 2. Having got this, you now say that after each half-life, after 20 days, we have 5 grams. 5 grams becoming half. That is 5 over 2. 2.5 grams left. Then after another 20 days, that is after 40 days, the activity has finished. It means 2.5 divided by 2. We are going to have 1.25 grams left. And that is the answer. Okay, you can decide to use this formula, which says N equals N0 times half raised to power number of half-lives, where N0 is the initial count, number of half-life. Initial count is 5 times half raised to power number of half-life should be 40 over 20, which is the same 2. 5 times half raised to power 2. And we have 5 times half raised to power 2 means half times half. And that is 1 over 4. 1 over 4 times 5 is going to give us what? 5 times 0.25. And that is 1.25 grams. The same answer. You can also decide to use this formula. N equals N0 e raised to power minus lambda t, where lambda is the decay constant. And the decay constant is mathematically 0.693 all over half-life. That is 0.693 over 20, which is a half-life. If you divide the two numbers, you are going to get 0.03465. That is the decay constant. Now, let's continue. The activity time, remember, is 40 days. So, N will give us 5, which is NO. Let me rewrite NO e raised to power minus lambda t, where NO is 5, e raised to power minus the lambda there is 0.03465 times t. The t is 40. So when you multiply the two numbers, 0.03465, you multiply it by 40, you are going to get minus 0.03465 times 40 will give you minus 1.386. So when you multiply this, or 5 times the base of natural logarithm raised to power minus 1.386 is going to give you 0.250. If you multiply the two, you get 1.25 grams. And that is the answer. See you next time.